Feel free to use the chat. Hello, Abhay. How are you?
Hey, Nico, I'm good. How are you doing?
I'm doing great. The weather finally is really great here in Greece. We have some sun. People are going out, like people are chilling. It's really lovely here. What about you? How's
Oh,
Toronto?
it's opposite of what you just said. It is overcast. It's a slight raining right now, like not heavy rains, but drizzle. But definitely there is no sun right now. So
Oh
it's
no.
it's exactly the opposite of where you are. So I'm
Yeah.
jealous of you right now.
I mean, it will get better. It will get better.
Yeah,
But
no, it will because we are almost end of April. So of course we have to be. Like today,
oh,
it's not the best. Like let me say that. But I think today is the best weather for to talk about supplemental lighting, even in the end of April, where I don't see a lot of natural sunlight. So yeah,
exactly. We don't have the sun, but we have like the lightning that you are here to talk us about.
yeah,
Everyone say hello to Abe and please let us know where are you from, where are you dialing. We will give 2 or 3 more minutes before we start. Hope everyone's doing great. I see some people are Bluebird in St. Paul. Hi from Newfoundland. Hope everyone's great. We remember here, eager to get some insights. Perfect, Lara. You're in the perfect place. I actually have a poll to do. Maybe we can do that. It will be fun.
yep.
Some
Please go ahead.
engagement. So let's go for a poll, guys. Let's see your location actually. Feel free to select your location so we can see like better where you are. Oh, I see right now. Okay. New York City. Hi, Ian. Hope you're great. British Columbia. Perfect. Hi, Michael. How are you? Thank you, everyone, from joining. Thank you. Thank you. Portugal. Perfect. We have a European here close to me. Hello from Greece. Feel free to vote. Hi, Kim. Hello. Hope everyone's doing great. Thank you for participating in this webinar, this exciting webinar. Like greenhouses, LEDs, everyone's talking about them, and actually what are the technologies around it? What is the evolution of LED? Where are we going right now? What is changing? And how is this thing affecting like plants and the nutrient uptake of the plants? Hello, Ken from Munich. Next week I will be in Leipzig. That's perfect. Hello from India, Mumbai. Hello, Ryan from. Oh, Ryan, we had a call with Say in Energy. Yeah, perfect. Hello from Iraq. Hello from Switzerland. Laura, hello, hello. Pennsylvania. Hello from Korea. Excited to see that. And hello from Saudi Arabia and Ontario, Leamington. Of course, Leamington, our favorite Leamington place. I'm editing the poll and I'm showing the results. Do you guys see the results? I bet do you see the results?
Yes, I do.
Most of the people are from North America, but we see people in Europe, Asia, Africa, and South America as well. Thank you, everyone. Thank you. And then we also have another poll to understand a little bit more about you guys. What are you? Who are you? What are you doing? Are you like a greenhouse operator? Are you a vertical farm grower? Are you a student? Who are you? Researcher, consultant, space ag enthusiast? Who are you? Oh, that's a lot. Okay, okay. I see the live polls right now, Abby. I see what's happening here. Perfect, perfect. Hello from US Davis. Hello, Muhammad. How are you? Consultant out there. I see, I see. Perfect. 36 people, 37 have voted as well. Come on, come on. I need 3 more answers to go to 40. Can we get those? Okay.
Yeah, I think it's good to see a lot of
There.
our attendees from all across the globe, actually.
Yeah, from Korea to Portugal to Saudi Arabia, India, US,
Yeah.
Canada. That's perfect. Hello from King City, Ontario. Hello, Lekha. Hello from South Africa. Hello, Peter. How are you? Perfect. Thank you, everyone. I'm also ending this poll and I'm sharing the results. We see most of you guys are in greenhouse and vertical farm growers. That's a perfect place to be here today. Researchers and consultants, hello and welcome. It's our pleasure to host you here. We are going to talk about impact of wavelengths on nutrient uptake. We have Abhay with us, who is the Chief Horticultural Specialist of Sollum Technology, a leading company about the lighting and the evolution of lighting for plants, especially in greenhouses. Before we start, I would like to introduce you to Agritecture, who we are and what we do. We are a consulting firm focusing in urban agriculture and controlled environment agriculture all around the world. So thank you everyone for being here today. We help people to end their projects, validate projects, help you with the concept, and actually create more projects of urban agriculture and controlled environment agriculture all around the world. So if you have any questions, if you want to learn more about what we do, please feel free to go at www.agritecture.com. It's a really nice website where we just launched, so we are also open to hearing your feedback. Some of the services of what we do, feasibility. Is your project going to work? What kind of technologies do you need? What kind of crops do you need to grow? Do you want to do hydroponics, aeroponics? Who is going to build the farm? All of these questions is answered by us. But most importantly, is the farm going to succeed or is it going to go bankrupt? These are the questions that we answer before you invest any dollar. We design farms, layouts, AutoCADs, 3Ds, everything you need to see like for farms we provide this to you. Like if you want like a vertical farm, greenhouse, open space, we have the expertise to do that. Architecture and master planning. If you have any architects who want to integrate agriculture into their plans, feel free to ask for us. If you're looking to invest in a greenhouse or a vertical farming facility, due diligence services are here for us. And of course, we work in agritourism and all over the urban agriculture environment. But what we really, really like is providing context for people and educating and doing like uh, giving more information to people about the sector and having like more impact with these solutions. That's why we're doing this awesome webinar today with Abe. And that's why we uploading on Agritecture YouTube videos about education. You can see like videos again about LEDs, about how vertical farms are switching their business model and everything you need to know about the industry. Of course, we're having more webinars. May 4th, May the 4th be with you. That's going to be an exciting one about space agriculture. And we're also doing one with Henry Gordon Smith, our CEO and founder, about climate smart agriculture and control environment agriculture. So if you want to join, let me know in the chat and I will give you the registration link. Of course, we're doing blog posts. That's how our company started. And the latest blog post that we really, really liked drafting is about the greenhouse lighting evolution. So if you guys know, like lighting in the greenhouses started with HPS. It was like a standard fixture that produced some light. And later we saw in the industry that the LEDs kinda is cheaper, kinda works better. But what is cheaper and better feels like? That's why today we have Abhay for Sollum Technology to let us know a little bit about what's happening right now in the dynamic LED, what are the newest trends, and how it affects also the nutrients of the plants. Abhay, please feel free to share your screen and give us your presentation. If you guys also want to ask questions, Q&A is open, and you can also like write in the chat.
Okay, I'm just trying to share my screen. Just a minute.
Sure.
Are you seeing
Perfect.
it
We can
or
see
not?
that you're sharing. Yes.
Can you see my PowerPoint?
It's loading right now, probably. I see a black screen. Mhm.
That's not good.
Not yet. Let's give some time, but let's talk about LEDs while we're waiting for it. Anyone knows what are the latest trends of LEDs? Does anyone know about that? What's the latest fixtures? what's happening in the LED industry. Which colors are the best? Do you guys know? Do you guys have any questions?
I'm not sure why I'm not able to share it right now. That's kind of weird. Okay,
Okay,
now I can see it. Okay, sorry about that.
all good. We can see it now.
Okay, cool.
Of course, you can
I
make it into
apologize.
bigger.
Sometimes the technology is good, sometimes it's not. So, all right, are you able to see it in full screen now?
Perfect. Yeah, that's awesome.
Awesome. So once again, I apologize. There was some glitch on my end, so it took me some time. But yeah, so today we are going to talk about the impact of wavelengths on the nutrient uptake, whereby we are using the dynamic LED lighting in growing operations. The reason for this topic is like in the past, we have talked about the different wavelengths, how they impact the crop. But at the same time, what I'm seeing more and more that I'm dealing with the growers is when I walk into the greenhouses, I see how the crop is responding to the different wavelengths, to the different spectrum. We are also seeing some deficiencies in the plants, and the reason for that is the plant is taking up some specific nutrients, and that's when we try to rectify those, and we see that okay, why is this happening now? And that's why I was like intrigued to see okay, at least I need to dive more into the research and see what is like how are the wavelengths impacting the uptake of the nutrients, so that way I can better assist our the growers and help them to ensure that they succeed with the dynamic led lighting. So that's the reason that drove me towards this topic. Of course, it's not that you will get everything today, because I'm just scratching the surface, to be honest, because as we speak I'm still learning, which I do every single day. So today we are going to dive into this, and we'll first understand the impact of wavelength on the plants. I just want to do a recap so that we understand how the wavelengths impact the plant growth. Then we will look at the nutrient uptake under specific wavelengths. Again, this is not something that I have researched, but I have done a review of literature. A lot of different scientists have already studied the impact of different wavelengths, and I have took their research and tried to present it. But at the same time, we will also look at how to use these research findings for practical applications, because that's exactly more important for us. Say, for example, you have our Solum fixture, and if I'm not able to assist you in how you can improve the crop performance, that would not be good. So that's the reason that we will also look into the practical applications. And of course, we'll take some questions in the end. So to begin with, we are looking at some of the research proof points. Again, this is a well-known fact if you're not already aware, but this is already the research that has been done by Epp Hewling and Leo Marcellus at Wageningen University. Based on this research, you can increase the red fraction in the LEDs, and you can get a better production in lettuce. And this is, I'm just targeting lettuce right now, but it has also been, the research has also been done on other crops as well. So what happens is, as you increase, there's a linear increase in fresh weight with the increase in red percentage. So as you move from say 50 or 60% of red, which is like the white light, what we call, towards a more pinkish light or towards a more red dominant fixture, where nowadays with the new technology you can even go up to 100% red wavelength, which really works. I have seen it, as you can see even in the picture behind on my screen. We are able to actually use the red wavelength at certain times of the day at a certain growth stage of the crop, depending on your environmental conditions, of course, but it does have a very significant impact on the crop growth. Again, I'm just taking the research that I have here and try to apply it in practical. I'm seeing the same results. I'm seeing the linear increase in fresh weight when I dial it to a higher red percentage wavelength, or even to 100% red wavelength. The another advantage that you can have, so the plants are definitely having an impact because of the higher red wavelength. They are responding by giving a better production. However, for the grower or the owner, it is also important because the more you have with a higher red wavelength, the more efficient the fixture would be. What that means is the electrical consumption would be much less if you're just pushing the red wavelength. And that's where it is a win-win for both the crops as well as the greenhouse owner or the grower. So when we see that, I was more intrigued to dive into, okay, let's talk about the red light and the blue light only and see where these wavelengths are having a major impact. So I came across this very good research paper. I have it on the screen. Feel free. You can download the whole research paper and read it at your own convenience too. So the red light, it is more like if you are looking at the morphological traits, like we know it is important for flower induction, vegetative growth, control of height. Of course, we know far red will give you the stretch, root biomass production, and control of transpirations. As you see, as we go into these other traits, we see the shift between the red and blue light. So both of them are equally contributing to having these traits in the plant. When we talk about the nutrient uptake, we see the root elongation is much more impacted by the red light. However, the lateral root formation is more because of the blue light. And this is something that I have recently, I was at a greenhouse grower, and we just saw that applying the blue light only for certain times of the day, we were able to get a much better lateral root formation compared to broad spectrum or LED, a static LED light. So this is where the dynamic light and the use of different wavelengths comes into play. Now, along with the lateral root formation and the blue light, there also comes the uptake of the mineral nutrients, which we will dive into it later. So as you can see here, even for the secondary metabolites, a lot of that blue light is essential to increase the phenols, the anthocyanins, and the antioxidant capacity of the crop. So this is where we use that specific wavelength for if you want to have some specific objectives in terms of quality, whether it is lettuce, whether it is other leafy greens, tomatoes, strawberries, or even cannabis for that purpose. So let's get into the crop specific nutrient responses. Let's talk about lettuce. So the use of the single spectral blue or red LEDs increases the biomass accumulation. It also increases the anthocyanin concentration. We know about it. Now, what does it do with the monochromatic red? It increases the accumulation of nitrogen and magnesium in lettuce leaves. So what does this mean? Like if I am moving my spectrum towards a higher red percentage, I need to make sure that I adjust my irrigation strategy accordingly. That's the main thing that I wanted to bring to this webinar, that yes, we have the knowledge, but how are we going to shift and how are we going to use that knowledge and make some fine tuning to our culture practice in the current crop. Now, there's another research paper which really fascinates me. I like this very much, which is called the Blue Light Sonata. Many of you might have already read about it. If not, feel free. It's a really good research paper. To sum it up, what it says that dynamic treatments with short blue light exposure during the morning and as well as in the evening improves the fresh weight and leaf area compared to static LED lights. This is very important. Now, you need to understand that when you are applying like just a short blue light exposure, what that means is, of course, we are not targeting 200, 300 micromoles of blue light only, because practically that would not be possible in the commercial LED application. However, when you're applying even a smaller blue light PPFD, I would say, anywhere between 40 to 60 or 70 micromoles. What happens is that at that particular point, with that amount of blue light, your LED lights are not consuming a whole lot. So say, for example, if you have a 1,000 watt LED, and if you are only giving the plants 50, 60, or 70 micromoles of 100% blue light, at that point, your fixture would consume maybe 200 or 300 watts. I'm just giving an approximate number just to let you know that it's a relatively very low wattage usage. So the power usage is very low. However, look at the results that you would get. It significantly improve the fresh rate as well as the leaf area compared to a static LED, like a fixed spectrum LED application. So these are the things that are important for the grower. Now, when we talk about, and this is something that is already happening in Europe, where they're looking at the nitrate levels, which should be less than 5,000 milligrams per kilogram. That is the standard that they have established. Now, when you try to push the crop, of course, as a grower, you want to have a much better production in terms of kilos per square meter. And as a result, we want to push the crop. And that would be everything. That would mean better light level or higher light levels along with temperature, humidity, and very important, you're also feeding the crop with a higher EC in order to ensure that the crop uses all those nutrients because it is getting the temperature, light, humidity, airflow to get to the optimum production. So when you try to do that, of course, your nitrate levels boost, they go really high. Yeah, but there are solutions now. If you have a 4-channel dynamic spectrum, as you can see here, the red light, it stimulates the nitrate reductase activity. So what does it do is, with a high intensity exposure to the crop, as you can see, uh, it can significantly lower the nitrate concentration. You know, so how it can be applied? You can just use the 100% red light, maybe just 2 or 3 days before you harvest the crop. So you can really push the crop until the last 24 to 48 hours before the harvest. And then in those last 24 to 48 hours, you can change the spectrum easily. And I'll show you later on how we can do it practically. And you can achieve or you can reduce the nitrate levels. And now all of a sudden, you don't have to worry about the standards or getting the product being rejected. If we talk about the blue light, it increases the overall nitrogen content. It is less efficient for nitrate reduction in mature plants. So that's the result. We won't use the blue light, but we would use the red light if your objective is to reduce the nitrate levels. And then for far red light, it's definitely not recommended for nitrate reduction strategies. So this is how the different wavelengths can be used to achieve the specific objectives of the growers. So adapting the light spectrum, especially increasing the red light, does help ensure the compliance with the EU nitrate thresholds. All right, so moving forward, let's talk about some other crops, mustard and kale. So increasing the portion of blue light relative to the red light resulted in a higher content of all mineral nutrients in mustard and kale. So now this is where, if you have a fixed spectrum, say for example, 85% red, 5% green, 5% blue, 5% far red, guess what? You are stuck with that spectrum for the next 10, 15 years. And the reason I say 10, 15 years is most of the LEDs have the lifespan of around 50,000 hours. Typically, you would use only about 2,000 to 3,000 hours per year. So if you look at that, you're going to be sitting on those lights, or the lights are going to be hanging in the greenhouse for the next 15 years. So if you have different crops rotating in the greenhouse, it's definitely the 4-channel dynamic lighting is the way to go. So now you can adjust the blue light relative to the red light if you are growing mustard and kale in that particular bay, just as you see in the picture here. In one of the side, you see a very high blue content, and right beside it, you see a much broader spectrum. So that's how you can really form the zones in the greenhouse and ensure the right lighting wavelength for the crop. So another thing was with the 50%, like there were different blue to red ratios that were trialed in this particular research paper, and they did find higher concentrations of calcium, phosphorus, boron, and magnesium. The positive effects of higher blue light are very species specific. We have seen that, dependent on the nutrient element, which nutrient element it has been targeting, and also dependent on the blue to red light ratio. Let's talk more about it. So high sulfur content was found only in mustard, in the same where it was a higher blue percentage. The high copper, zinc, and potassium content in kale, and high content of all nutrients was also found in kale under the blue at 75 and red 25 ratio. So a higher percentage of blue, lower percentage of red. Now, the physiological basis of the blue light properties, they rely on the control of the phototropin receptor. So that's a lot more physiological concept. We can dive in later, or someone who is interested, they can go in and read more about it. But the blue light also promotes the ion channel opening, encouraging ion transport. So we have also seen that the blue light also encourages the stomatal conductance, increases the stomatal conductance, the stomates open, so also promotes the ion channel opening, encouraging the ion transport. Now, the sprouting broccoli with a higher red to blue ratio resulted in the highest levels of a lot of the elements as you see listed over here. So what I'm trying to say is the wavelengths do have an impact on the mineral nutrient uptake. And when it does, you need to adjust your irrigation in terms of what you're feeding the crop in different stages. So if you are changing the lighting spectrum, make sure you don't just do that, but ensure that you're also managing your temperature, humidity, airflow, along with your fertigation techniques. Let's dive a little more into coriander. The application of red light as a sole source lighting system led to significant decrease in antioxidant properties compared to the three ratios of red to blue that were applied. And the key insight here is the various bioactive compounds respond differently to the light treatments. This is important. And their biosynthesis is expected to be promoted in a species and cultivar specific manner. So again, there is no one thing or one size that fits, one spectrum that fits for all the crop, because then the crops are adjusting to the light. It should be the other way around. The lighting or the spectrum should adjust to the needs of the crop. Okay. Let's look into a few more crops here just to give you an idea of how diverse it could be. So in okra, the highest calcium, phosphorus, and manganese values were obtained under red light alone. So if you're growing okra in the greenhouse, guess what? 100% red light is definitely driving the calcium, phosphorus, and manganese values, and make sure that you're feeding the crop with the correct amounts of calcium, phosphorus, and manganese in order to avoid any deficiency symptoms. Same way for peppers that were harvested, fruit illuminated with a higher blue light. We know that blue light pushes higher anthocyanin pigmentation, and they also showed a delay in ripening process. Okay, so which is great. So what that means is if there's a delay in ripening process, it would have a much better shelf life. So it is going to have an impact on the shelf life. What does it do? Customer retention. If you have a customer and they are buying from you on a regular basis and they see that if I buy from grower A, I get a better shelf life out of my peppers, guess what? They are going to be a repeat customer for you all the time. So this really helps in customer retention. Also in flowers, in cut carnation, the sole source blue light, it can be used in the cold storage. And again, if you're using it at a very low micromole levels or ppfd, you're not spending a lot more in energy, but what you're getting is a prolonged vase life, which is important. Again, you bring the cut carnation at home, you put it in a nice flower vase, and if it's going to stay there for 7 to 10 days or 14 days, you would be much happier customer and would go back and buy the same carnation which were grown in that particular greenhouse. So that being said, let's also talk about tomatoes, cucumbers. So when in for tomatoes, especially when red wavelength was used as a supplemental light source in the greenhouse, the potassium, magnesium, and calcium content in the whole tomato fruit increased by 30, 74, and 40% compared to the HPS. So you can see that there is so much impact on the uptake of the nutrients. Now, how is that going to translate? If you are going to have the right lighting strategy, the light environmental strategy, and as you can see here, if you're going to feed the crop properly, all of that increased uptake, it's not going to go waste, right? It is going to get translocated. And where would it get translocated? Initially, maybe in the root system to have a nice root system. But once you have that established, that's going to be translocated as sugars into the fruit. You are going to see a benefit in the production. So when we say that if you're doing a certain, like we have a business case, you can go to our website, we are seeing that under a dynamic LED lighting solution compared to a static LED lighting solution, we see almost 20%, like it's 19.2%, if I remember it correctly, increase in the tomato production. Now I know why, right? Because I see that when I'm having that dynamic lighting spectrum, which I have as a lighting strategy, the plants are having a uptake of more uptake of potassium, magnesium, calcium, which is helping in the production. Now, for cucumbers, also the red light has reported to have a positive impact on the potassium absorption in cucumber and spinach, whereas the content of potassium was found to be lower under blue light. So what do we do here? If you have a 4-channel dynamic LED lighting, you can easily switch between the ratios of red to blue. You can go to 100% blue, 100% red, and you can achieve all these different results. Also, not to, on the other hand, in the Chinese chive and garlic, the blue light enhanced the potassium uptake. So as you can see, we are going through diverse crops, a lot of different crops, and you see different impact on different crops, on the uptake of the different elements. Not to leave the strawberries, let's talk about strawberries. So impact of the light spectrum on anthocyanins, which is important. We know the red coloration of the strawberries. So blue and red light treatments resulted in significantly higher levels of total anthocyanins. And the highest and fastest stimulation was obtained under blue light exposure. Again, what can we do? You can have the blue light only, and you can use it to improve the anthocyanin pigmentation. Now, a lot of times the growers would ask me, yeah, so do I need to run the blue lights the whole day long? Absolutely not. No, you don't need to do it. There are different strategies that we can deploy based on your greenhouse. So if any one of you needs some more information on how to have the lighting strategies along with the environmental strategies and the fertigation strategies, in the end, you will have my email address and my contact information. Please feel free to reach out and we can talk on one-to-one basis because each greenhouse is different. I cannot give one solution that fits for everyone. It is more generic. However, I can work individually with you guys to develop a customized solution for your application and your objectives. All right, so moving forward, I won't go through all of these. As you can read here on the slide, that the effect of red light, it also helps in promoting the synthesis of proanthocyanins, anthocyanin concentration, and the upregulation of leuanthocyanide reductase and anthocyanidin reductase as well. Excuse me. Now, the question is how to use the scientific references in practical application. So let's look at that. So in order to explain that, I have taken this another research paper as an example, which has the influence of LED lighting spectrum on hydroponically grown lettuce. So what they have done here is they have these four different LED lighting ratios where you can see the red ratio goes from 88% to 81%, which is the LED4. The same thing with the green, blue, and far red. And also they have the HPS in here. Now, what they saw was with the LED4, which does have the far red and 81% of red with blue and green, they saw the maximum fresh weight. Okay. The reason I'm building this background is to show you how I use the data in practical application. So I went through this research paper. I saw that, okay, if I go to the previous slide, if I have a far red of say 11.6, say anywhere between 11 to 12%, that is going to help me to get some increase in the fresh weight that I see as per this research paper. Okay, so that is it already in my mind. If I look at the macronutrients and the micronutrients, I see that there is a really good uptake of nitrogen, phosphorus. Look at potassium and calcium. There's a really heavy uptake of potassium, calcium, and magnesium. So I need to keep that in mind along with iron. So now, when I go to the greenhouse and I say to my greenhouse, okay, so if I have a greenhouse where I'm growing the lettuce, basil, arugula, so first of all, what I do is because I have the Solum 4-channel advanced dynamic lighting LED along with the Sun as a Service software, which allows me to get the different zones just by the click of a mouse. I would click my mouse and I would form a zone just for the lettuce where I have it just for one bay or two bays. Then I'll form a zone for basil, and then I'll form a third zone for arugula. This is just for as an example. Now within lettuce, what I have seen, I have this research paper. Based on that, now I'm dividing it further into the first 7 days after germination, the growth phase, the production phase, and the finishing phase. Again, you're seeing different colored dots over here, which is purple, yellow, red, and black. What that shows you is I can form further zones with my 4-channel advanced dynamic LED lighting solution from Solum using the Sun as a software where I can just select the fixtures for the first 7 days for germination, select the fixtures just for the growth phase. Similarly for production and finishing. What that does is that helps me to have a different lighting spectrum, different targets in terms of DLI, PPFD, which I can use depending on the different growth stages. So what I do is for the first 7 days of germination, I have a different strategy for lighting as well as irrigation. And when I say irrigation or fertigation, that includes the fertigation or the EC that I will be providing to the crop. So as I learned from the research paper, to give an example for the finishing phase, so okay, to back off a little bit, I don't need the 11 to 12% far red in the first 7 days after germination. The reason for that, I really want to have a nice compact plant without the stretch. Because if I have that 11 or 12% far red, it's going to stretch a lot. And I really don't want to have that. So what I will do is my lighting strategy for the first 7 days will be probably with a higher blue percentage, right? In order to keep the plants nice and compact. Similarly, I will have a different lighting strategy for the growth phase, for the production phase, and I will manage my fertigation to make sure that I am providing the right elements to the crop along with the lighting strategy. Now for the finishing, I'll definitely like to put in 11 to 12% of far red because based on the research paper, I will see an expansion in the leaves. I will see a higher fresh weight, and fresh weight is what matters to the growers because that's what they are selling, not the dry weight. So just for the last few days before harvest, so maybe 2 or 3 days before harvest, I will change my lighting strategy. Along with that, I know that it's going to uptake more of the nitrogen, calcium, potassium, iron, manganese. So it was magnesium, sorry. So I'm going to change my fertigation strategy for the last 2 or 3 days before harvest to ensure that I have the best production or the maximum production just in the last 2 or 3 days. So I will push the crops. So going from the first 7 days after germination, I like to keep it compact. I like to have the crop grow in the growth phase and the production phase. But then in the finishing phase, I really want to make sure that I'm getting the maximum out of my square meter, like maximum kilos per square meter. So this is how we can deploy it. And this is not a cookie cutter. It will differ for each greenhouse depending on your environmental conditions, depending on your infrastructure. So again, feel free to reach out and we can look into the customized solution for your greenhouse. So just to summarize, again, I won't read the whole slide, but as you can see that it will differ depending on the cultivar, the growing environmental conditions, and the total light intensity. So the nutrient uptake depends on a lot of different factors. It's not that, yes, the blue light will only do this or red light will do this. Take it as a reference. Okay, because if you have a different temperature, if you have a different humidity, if you have different growing environment, guess what? The plant is going to react differently. So keep that in mind. Uh, the technology, of course, you would need the 4-channel dynamic LED lighting in order to make sure that you are able to switch between the individual wavelengths. Because a lot of times you see that the growers say, well, I don't need 4-channel, I can do with 3-channel just to save a few cents, for per micromole for the fixture. But that doesn't help because when you have 3 channels, what happens is if you have red on one, far red on the second channel, and then you have blue and green on the third channel, guess what? The blue and green actually have antagonistic effect. So green actually rubs off the effect of blue that you're getting. So if you really want to have the impact of blue, but if you're also adding 50% of the ppfd of green, guess what? It's going to nullify the effect of blue. So that's really not helpful. So if you want to go with the 4-channel advanced dynamic LED lighting solution. And also the last thing is zoning, which is very important and very easy to do with the Sun as a software um, from Sollum Technologies. So you can just with the click of the mouse, you can select the fixtures. There is no need to rewire. There is no need to change the breakers. Once the lights are installed in the greenhouse, you can form the zones as many zones as you want, you know, and you can deploy the different lighting strategies, lighting recipes, and you can succeed. And yeah, just to finish it off, this is the new fixture that Solum has been promoting right now since the beginning of this year. This is the SF Infinite, where you get all the 4 channels, and you can really go from either blue, just 100% blue, or 100% green, 100% red, or even 100% far red, or a combination of any of these in different percentages. So it's a really one fixture with infinite possibilities in real sense. And in order to do that, very easy to use a user-friendly software that you can get along with the fixture. So with that, I do have some references here which I had used. So feel free to reach out, or as if you have been looking at the slides, you can also take a look at the original research paper. So here is my contact information for all of you. And I think please reach out to me if you have any particular questions regarding your greenhouse operation. And I would be glad to connect with you on a personal level. And we can discuss how we can provide you the best solution possible. So with that, I think, Niko, I will stop sharing.
Yeah, thank you so much for the presentation. It was really insightful, Abhay, as always. I have one question regarding your fixture one fixture fits all. How it's also connected with your software, because you guys have a software, you might want to discuss a little bit about that and how this automation can be like really easy and really adjustable to every grower's needs. Can you tell us a little bit about
Yeah,
that aspect?
yeah. So the Sun as a software, that is something that we do take pride in what we provide to our customers. It's a really easy to use software where you can use it in terms of adjust the DLI thresholds. You can adjust the PPFT thresholds. Even there is a predictive DLI mechanism that we provide in there. You can also provide, there are a lot of different, I would say, toggle switches that you can turn on and off as per the requirement of the crop and the needs of the grower, in order to get to the correct PPFT and DLI. So we also provide our own sensor, which will take into consideration the natural light levels as well as the supplemental light levels. And depending on that, it will either dim the fixture or it can even change the spectrum of the fixture, which the growers don't need to do it manually. They can just set the parameters, and based on the natural light levels, the spectrum of the fixture will change. So if they want, say for example, they want it to go to a higher red percentage when you have enough sunlight, you put the parameters in the software and the fixture will automatically start turning a lot more higher red percentage, just as you see behind my screen.
Perfect. So growers can like grow with like just put the idea out there into the software and then the software with the dynamic lighting, the
Yep.
fixture like makes everything. Wow,
Yeah,
that's
and one other thing I just want to say, because a lot of time I do get this question, that how easily is it compatible with my existing climate computer? So if you have
hmm
like Argus, Pliva, Hugendon, Wadsworth, Reader, no issues. It can
no
really
issues.
connect.
Wow.
Yep, you can. It's seamlessly connected with any of the existing climate computer, so you can use it along with your existing climate computer.
Perfect. Awesome. Thank you for answering my question. So now let's go to some questions for our viewers. If you guys have any questions, please let us know even on the chat or on the Q&A. I have some questions right now, which we'll try to go through as much as possible. So let's start with Mike Mikhail question. So the question is like, what lighting strategy would you implement if you want to maximize shelf life in peppers using the blue light down regulation of the ripening process? Does the plant need the same spectrum throughout, or can it change to the spectrum, or can the change to be the spectrum be made a few days before harvest to see the benefits?
Yep. So, as I was saying earlier, based on what the review of literature says and what practical experience we have, is the lighting strategy for the growth of the peppers. You would implement a lighting strategy, which would definitely not be a narrow spectrum. It wouldn't be 100% blue, 100% red throughout the growth. It will be a much more balanced spectrum. However, what you could do is you could use the blue light only, maybe in the beginning of the day or in the end of the day, in order to get that, to ensure that you have a better shelf life. So that's where you can deploy these different lighting strategies. Because I know you would have the peppers in different stages, so you definitely don't want to have like blue light only for 3 days, because that's going to have an impact on the other younger peppers on the plant. So that's how it is important that you think about the crop in a practical manner and apply these strategies accordingly.
That's perfect. And with this answer, you also answered the question from Ed. But let's go in a question from Said, where he says, like, Abe, have you observed any effects on different varieties of the same crop, particularly those with slightly different leaf colors on the red-blue light ratio? And he is also thanking for your insights in the webinar.
Yeah, yeah, no, absolutely. So it will definitely be, and I'm assuming he's talking about the same crop but different varieties, right? Yep,
Yep.
absolutely. Yeah, there is a varietal impact. Like different varieties will react differently. It's not that it's always the same. So absolutely, you're spot on, Said. It will
Mhm.
have a different impact. That's what we have observed. Again, is it something that happens always? Maybe not, because we also know, and probably you're also aware, that your growing environmental condition, the temperature, humidity also plays an important role. Especially if you're asking about anthocyanin pigmentation, that also has a role in it. So if it is for the root growth or for any other objectives, we can discuss that. But absolutely, different varieties will respond differently, for sure.
Perfect. That's great. And regarding, that's my question. Like, regarding flowering crops or peppers or strawberries, actually strawberries, we see a significant, like people are getting into strawberries in greenhouses lately. How would you make the spectrum recipe throughout like the growing stage? What do you think is like a correct recipe for a flowering crop like strawberries? And yeah, actually that's my question. Like, should we go with only red, only blue, a combination of that? Should we change it at the end? Regarding strawberries, what do you think is the best one up there?
Yep. So one of the things is a lot of times people think that when I say you go with 100% red, they think that, oh, that's that's not right. You cannot do that in certain times of the year. I 100% agree, and I never said that you do it in the dead of the winter. That's exactly where the sun as a software comes into play.
Hmm.
So to answer your question, what we could do is, say for example, if you are growing strawberries, you would start with a balanced recipe with a certain percentage of red, blue, green, and far red, because we know strawberries do benefit with the far red. So you would use that. However, what happens is when you're growing in the greenhouse, and depending where you are growing in the greenhouse in the winter months, if you are in Europe, you'll probably get maybe 1 to 2 micromoles of natural sunlight. However, if you are in Leamington, Ontario, in Canada, you could probably get anywhere between 6 to 8 moles of
Hmm.
natural sunlight during the winter months. And if you're in Florida or California, you would probably get anywhere between 12 moles or 13 moles of natural sunlight even during the winter months. So now, this is exactly where the lighting strategy will change, whether you're growing in Europe,
Uh-huh.
whether you're growing the strawberries in Leamington, or if you're growing the strawberries in Florida. So for someone to say, oh, the 100% red light doesn't work, no, you didn't get it, because I wasn't saying that you apply the 100% red light in the dead of the winter when you're not getting enough natural
Hmm.
sunlight. That would be absolutely stupid to even do that, right?
Yeah.
However, if you're in Florida, or even if you're in Leamington, if you're getting a natural sunlight where you're measuring 300, 400 micromoles inside the greenhouse of natural sunlight, guess what? At that time, the plant is already getting what I call as the percentage of the blue, the green, and the far red from the natural sunlight. At that point, for those hours, and I know in winter it would be 5 or 6 hours only where you are getting that much light. For those hours, your LED lights can move towards a higher red percentage, or even to 100% red. And that could be even for the tomatoes, cucumbers, peppers, strawberries, and even lettuce. And you can do that only in that during that duration when you're getting. Now, are the growers going to run to their computer to change it every time they see the sunlight? No. And that's where the software helps them do it. So they just put in the parameters that if I have natural sunlight of 300 micromoles or more, I want a higher red percentage. That's it.
Hmm.
And our software will take that into consideration. As soon as the sensors they sense the higher natural sunlight, the lights will start turning the spectrum towards a higher red percentage. So that's exactly where the AI, comes into play, because Solum is also a tech company. It,
Yeah.
it
This
does.
is the evolution as we discussed. Yeah,
Yeah,
this is like the next
exactly.
level.
That's why the growers can focus on the growing rather than thinking, oh, there is sunlight, I need to change it to a higher red percent. No,
What can I
the
do?
lights
Yeah.
will automatically do it. You don't have to worry about it.
Perfect. That's look at that, guys. Like amazing. Like you just imagine what you want to do, and then Solum and Sun as a service makes it for you. That's perfect. So we only have 5 more minutes. Let's go through one more question, probably, which is more
Yeah.
about lettuce. It's from Mikhail. Again, Mikhail, it's your lucky day today. Also, we will reply to the other questions through email, guys. So feel free to send more questions after the webinar. Next week, probably we're going to reply to more. If you have any questions directly to Abe, feel free as well. So the question says, what type of light spectrum or recipe would you use for dark pigmented lettuce varieties compared to green lettuce? So the question is about lettuce and different varieties.
Yep, yep. So again, as I showed you in one of my slides, for the first 7 days right after growth, you know, right after germination, sorry, the first 7 days, then you have the growth phase, you have the production phase, and then you have the finishing phase. So there wouldn't be one recipe or one light spectrum that I would use throughout the growth from right after germination to harvest, whether it is a green lettuce or whether it is a dark pigmented lettuce varieties. So specifically for dark pigmented lettuce varieties, we know that they benefit from a higher blue percentage. So obviously I will be looking at that. Excuse me, right after the germination, I'll focus with a higher blue percentage and continue that throughout the end. Now, especially during the last maybe 24 to 48 hours or 72 hours max before harvest, I would like to even push it even further with even 100% blue for a certain hours at the end of the day to have a really good dark red coloration or anthocyanin pigmentation in those red leaf lettuce. So, which I wouldn't have for the green leaf lettuce, because for the green leaf lettuce, I would do the opposite. I would rather push a little bit more of the far red in order to get even a much better weight in terms of kilos per square meter. Okay, so that is how I would adjust my lighting strategies depending on the different cultivars.
Perfect. Thank you for that. And Nabil, let's go for two final questions, which I find really interesting.
Okay.
One is really exciting. Would this study, I mean, like all of your research right now, be applied for indoor vertical growing? So probably vertical farming.
Yes. The short answer, yes.
The short answer is yes. So, hey Young Kim, if you have like more questions, let us know. But short answer is yes. This can be applied to indoor vertical farming, and I guess like the solution now for vertical farming is going to be game changer, guys. And let's go through the last and final question here from Son Fisher. Are you using machine learning with video slash photos to tune the lightning wavelength?
Sorry, can you repeat that? We are
Yeah,
using
like
machine learning for what?
are you using machine learning with video or photos to tune the lightning wavelength?
Not yet. So right now we are
Mhm.
not using the machine learning. It is more human learning, I would say. My background is growing. I was a grower in my past life for 12 years. So I'm using that experience with the grower's eyes. And along with our customer growers, we work with them closely. So it is more not a machine learning, but human learning for sure.
Perfect, that's great. And I guess like also like the Solum, the fixture gets a lot of data, environmental data, and like also like the energy data. So you combine some
Yes.
more data that we can see or our human brain can't like calculate so fast, which always gives the best results. Thank you so much
Yeah.
for the question. So, thank you, everyone. We are just right on time. Thanks, everyone, for participating. If you have any more questions, let us know in our emails. We will answer your email. We will answer your questions after your email. And also, this presentation will be uploaded on YouTube. So, take care. And Abe, thank you very, very much for this insightful conversation. I think what you guys are doing in Solom is like really encouraging for the industry. It helps a lot of growers. It helps us think better. Like we wish to have like great crops, and now you guys with Sun as a service and these fixtures, you do it. Like what the growers is wishing for, your technology is doing. So congratulations, very very much.
Yeah, thank you very much. And I would like to thank everyone on the call here for attending. And I'm sure the recording will also be available, right, Nico, if for
Yeah,
someone who has
exactly.
missed it. So yeah, and feel free to reach out for your any particular questions that you have. and I would be glad to engage with you in a conversation and help you out and provide you with some solutions.
Perfect. Thank you, everyone. Have a great day. Bye bye.
Bye.